Hello everybody, and welcome to an Algebra 1 video lesson. Today we're taking a look at section 8.3, which is all about graphing ax squared plus bx plus c. So, in the past we've talked about how to graph y equals ax squared and y equals ax squared plus c, as we learned in 8.1 and 8.2. Now we're moving on to the final version of the standard form of graphing. It looks like this. Before we do so, I want us to briefly review the things that we learned in 8.1 and 8.2. This a value shows up in 8.1 for the first time, and we learned 4 things about it. We learned what happens when a is positive, when a is negative, when a is greater than 1, and when a is between 0 and 1. Do you remember what happens with these different features? When a is positive, the graph points up, like a cup. When a is negative, it points down, like a frown. When a is greater than 1, we have a vertical stretch, meaning it's going to get narrower and taller. And when a is between 0 and 1, we get a vertical shrink, which means that it's going to get wider and shorter. These are all the things our a value controls. If you know what your a value is, you can identify one of these things. The c value also controls something, as we learned in 8.2. It controls how much up or down your y-intercept moves, or, as we learned in 8.2, our vertex. There's 2 features that our c value controls: when c is positive and when c is negative. When c is positive, our graph gets moved up, so we call it a translation up by c units. When c is negative, we call it a translation down by c units. This new value we're learning, the b value in the middle, is not like a and c. With a and c, if you know what a is or c is, you know how our graph has changed. But the b value is a little bit unpredictable. It is not possible to tell how much a graph changes by its b value, because the b value isn't just controlling something like moving up or moving down or moving left or moving right. It's controlling multiple of those things. Let's see what we're talking about. When you graph something that has a b value, y equals ax squared plus bx plus c, you get a graph that looks like this. Imagine here is our center of our graph, our origin, 0, 0. Our graph is sort of off to the right side and moved down. So we are now able to move our graph in many different directions. However, we're not sure how much the b value has moved it. So let's talk about a formula we're given here. This formula, x equals negative b over 2a, is the most important formula of this unit. This is the formula that tells you when you have a graph in standard form, such as, let's do y equals 3x squared minus 6x plus 3. This formula tells you what the x value of your vertex is. Because of that, it also tells you where your axis of symmetry is, because your axis of symmetry is just the line that goes through the vertex. So let's do this example here and use the formula. We have this equation in standard form, but we know that the x value of our vertex is equal to negative b over 2a. So we just need to plug in our b value of negative 6 and our a value of 3. So it's originally supposed to be negative b, but if our b value is negative 6, it's negative 6. And if our a value is 3, well, it's 2 times a. So we just change this a into whatever the a value is. Since a is 3, we plug in a 3 here. What's negative 6? Well, that's just 6. What's 2 times 3? That's also 6. We just got to simplify. What's 6 divided by 6? And the answer is 1. So in this case, our vertex would have an x value of 1. And we're going to talk about what to do here in a moment to find the other coordinate. So let's take a look at example 1. It says find the axis of symmetry and the vertex of the graph g of x equals 2x squared plus 8x minus 1. Well, we know we have a formula we can use to do so. X equals negative b over 2a. So let's identify our b value and our a value. The b value is whatever goes with your x, so it's 8. The a value is whatever is at the very start, so it's 2. So x equals negative 8, because again we're plugging in the 8 here, over 2 times 2. Well, negative 8 is just negative 8. 2 times 2 is 4. So what we're saying here is that x equals negative 8 divided by 4, or negative 2. That's our axis of symmetry. X equals negative 2 is just the answer for our axis of symmetry. But recall something very important. Your axis of symmetry is just the x value of your vertex. So we actually already know that our vertex is going to be at negative 2 something. What do we do whenever we know the x value of a function and we're trying to find the y value of a function? We have to plug it in. So if our equation is y equals 2x squared, and I know it says g of x here, but you can always substitute that for the letter y. If this is our equation here, we just have to plug in negative 2 and see what we get. So everywhere there's an x, we're changing it into a negative 2. So this is 2 times negative 2 squared plus 8 times negative 2 minus 1. Well, let's start off by doing negative 2 squared. Negative 2 squared is 4. So this is 2 times 4 plus, what's 8 times negative 2? Will be negative 16 minus 1. Let's simplify further. 2 times 4 is 8. So this is 8. Sorry, not 8 plus 16. Because this is negative 16, we can treat it as 8 minus 16 minus 1. 8 minus 16 is negative 8. Minus 1 is negative 9. So our vertex's y-coordinate is just negative 9. That's how you find the vertex when you have an equation. You just use x equals negative b over 2a, our big formula for this unit. What I want you to do is briefly pause the video and try out try number 1, then check your answer up here. Pause the video now. Overall, how did we do? When we use our formula here, we end up getting a fraction. We end up getting 1/3 as our axis of symmetry. X equals 1/3. So 1/3 is what we're plugging in for our vertex. As a reminder, you can always just plug this into your calculator if you are unsure of how to simplify it. There's no rule saying that you have to simplify by hand. But if you did want to simplify by hand, here's a trick that can help you. 1/3 squared, as a reminder, because we talked about this, is just 1 squared over 3 squared. 1 squared is 1, 3 squared is 9. That's where we got this 1/9 from. 3 times 1/9 is 3/9 or 1/3. So that's how we would do this. That's how we would do this problem. What about a graphing problem? We've done so many graphing problems here. Why is it any different? Well, in the past, we would use the numbers -2, -1, 0, 1, and 2 to make our graph. But I'm telling you right now, that is not the case anymore. Here's the reason. When we make a graph of y equals ax squared plus bx, you notice that our graph actually gets shifted a little bit. Our vertex is not at 0 anymore. That's not the middle of our graph. So why would we end up having 0 be the middle of our table? It just doesn't work. Instead, here's what we need to do. Find the middle of your table by finding your vertex. Let's see how we do that. We have a formula for the vertex. X equals -b over 2a. In this problem, our b value is -6, so it's -6. Divided by 2 times. Well, 3 is our a value, so that'd be 2 times 3. -6 is 6. 2 times 3 is also 6. The x value of our vertex ended up being 1, actually. So we should plug in 1 as the middle of our table, not 0. From here, to pick the rest of the numbers in your table, just start counting up as you go down, and start counting down as you go up. So we know that 1, 2, 3 would be counting up from 1. Counting down from 1, we go 1, 0, and -1. And now the problem is exactly the same as we've always done it. We're just going to go through and plug in each of these numbers into the equation and see what we get. I'll do the first one here with you all. We have y equals 3 times -1 squared minus 6 times -1 plus 5. Let's simplify it bit by bit. -1 squared is just 1, and 3 times 1 is just 3. -6 times -1 is +6, and we have a plus 5 at the end. 3 plus 6 plus 5 is 14. Pause the video and plug in the rest of the numbers here to see what points we can put on our graph. Then graph those points. Pause the video now. I just crossed it off. This is what your graph should look like, and this is what your table should look like. There's actually a built-in check to see if you did it right. If your vertex is supposed to be the middle of your graph, it should also be the middle of your table. And we learned that if you use the vertex as the middle of your table, the numbers above match the numbers below. So go 1 up and you get 5, go 1 down and you get 5. Go 2 up and you get 14, go 2 down and you get 14. So if your table looks the same on both sides, you know you've done it right with the correct center. Now I just need to analyze this graph. So it asks for the domain here. The domain of every parabola is all real numbers because it goes to the left forever and it goes to the right forever. That's what these arrows mean. For the range, this is the one that people always have a little bit of trouble with. Ask yourself, what's the lowest we ever go and what's the highest we ever go? The lowest y value we ever reach is 2. As for the highest y value, well, these arrows tell us it goes up forever. So we're going from 2 to infinity for our range. Before we continue, I want to talk about the transformations of this graph. Believe it or not, there are actually 3 transformations. And you can't get all the transformations just from looking at the equation anymore. Remember, a b value messes up the graph in ways that we can't predict. But we can see what the result is. Let's start by looking at the equation. Your a value is always still going to tell you how much we have a vertical stretch or shrink. Our a value is 3. So we know we have a vertical stretch by a factor of 3. Just like we've been doing it since 8.1. But here's a question. Our c value is 5. Did our graph suddenly move up 5? Starting at 0? No, it looks like it only moved up 2. Like I said, the b value changes our graph in ways that we can't predict. We don't treat our c value as our vertical translation anymore. In truth, this c value of 5 is your y-intercept. Notice that our graph is at 0, 5. So how do we tell how much we've moved up or to the sides? By graphing. If we look here, it looks like our graph has moved up 2 units and to the right 1 unit. So we have a vertical translation up 2. And when we move to the left or right, we use the word horizontal. So this is a horizontal translation, right 1. So when we actually go through and do this problem, we will have 3 transformations. I'd like you to you try number 2. Pause the video and give it a shot. How did we do, folks? This one's a little bit trickier because the numbers are a little bit bigger, but the idea is still the same. Step number 1 is to find your vertex. Here, we know that our x value of the vertex is -1, so we can then plug in -1 to find -1, 3. Step 2 is to construct the rest of your table around -1, so we use 0, 1, -2, -3, and then we can graph it. Almost done, folks. I want to talk about minimum and maximum values here. A minimum / maximum is the same way of saying what's your highest point or what's your lowest point, just like how we do with the range. So when we talk about a maximum, the maximum is the highest point. The minimum is the lowest point. The y value of the vertex is always going to be your maximum or minimum. So if I ask you, hey, can you tell whether this has a minimum or a maximum value? Then find the value. We have to just find the vertex. But the first question is, do we have a maximum or do we have a minimum? Well, as we can tell from this diagram, it really depends on what way our graph is facing. When our a value is negative, our graph is down like a frown. So we have a maximum value at the very top. When our a value is positive, it's up like a cup. So we actually have a minimum value. We have a bottom of the cup. So when we take a look at example 3, we first need to ask, is our graph up like a cup or down like a frown? Since our a value here is -4, we know that's going to be down like a frown. And if it's down like a frown, we actually have a highest point. So we have a maximum. Then it says to find the actual value of the vertex. So to do that, we use our formula. X equals -b/2a. Our b value is -24. Our a value is negative 4. Negative negative 24 is positive 24. 2 times negative 4 is negative 8. So the x value of our vertex is negative 3. But it's asking for the value of the vertex, so we also need to find the y value of the vertex. And to do that, we just plug in negative 3. So we get negative 4 times negative 3 squared minus 24 times negative 3 minus 19. Negative 3 squared is 9, and negative 4 times 9 is negative 36. Two negatives make a positive here, so negative 24 times negative 3 is going to be positive 72. And then we have the minus 19 here. This one's going to be a little bit tougher to add because the numbers are a little bit bigger, but we should get 36 minus 19, or 17 for the y value. All right. Almost done here, folks. We just have 2 word problems to take a look at. So, let's talk Michigan. The suspension cables between 2 towers of the Mackinac Bridge in Michigan form a parabola to be modeled by this equation, where y and x are measured in feet. It's asking us to find the height of the cable above the water at its lowest point. Ooh. Whenever a problem is asking us about its lowest point or its highest point, that sounds a lot like minimum or maximum. Oops, not minimum, minimum. It sounds a lot like minimum or maximum. So it's asking us, hey, can you find the minimum of this equation here? And the answer is absolutely we can. We just have to find the vertex. So even though the numbers look weird here, our formula stays constant. X equals negative b over 2a is the name of the game for today. So x equals negative 0.37 divided by 2 times, our a value is actually very, very small. It's 0.000098. This is one that I would almost recommend using your calculator for. So we know that negative 0.37 is going to be 0.37. We know that 2 times 0.000098 is going to be, well, our calculator gives us this. This is something that is in scientific notation. If you want to get out of scientific notation, I believe you can just go to mode. Oh, it seems like we are in normal mode. All right, then here's a trick to help you out with the problem like this. In this problem, it suddenly turned to 1.96 e to the negative 4th. E to the negative 4th tells you how many movements you have to do for the decimal place. So this tells us we have to move the decimal 4 places to the left, so it'll be 0.000196. If we do 0.37 divided by 0.000196, we get this. This is the x value of our vertex. But we don't want the x value of our vertex. We want the height of the cable. So we just have to plug it into our equation once more. Our equation is y equals 0.000098 times x squared. So we'll plug in our x value here, minus 0.37 times, once again, our x value, and then we will add 552, and we'll see what we get. It's going to be a long one to plug in, so we can plug it in here. 1887.76 squared minus 0.37 times 1887.76 here, plus 552 tells us the height of the bridge is about 202.77 feet. That's it for the lesson for today, everybody. I hope you have a fantastic day, and I'll catch you next time.